Ever seen the movie Terminator 2?
Yeah, who hasn't?
Well, remember that T-1000, the shape-shifting robot made of liquid metal?
Oh, yeah, pretty terrifying and cool all at the same time.
It made me wonder, what if materials could think and react like that in real life?
That's a great question, and honestly, we are getting kind of close.
Oh, tell me more.
Well, today, let's dive into the world of smart materials that respond to stimuli, especially something called magnetorheological fluids.
Magnetorheological fluids.
Or we can just call them MR fluids.
Okay, MR fluids. What are those and how do they work?
Imagine a fluid that can transform from a liquid to almost a solid instantly just by using a magnet.
Wow, really? That sounds like something straight out of science fiction.
It does, doesn't it? But it's real, and we see it all the time. Before we dive in, are you familiar with the difference between Newtonian and non-Newtonian fluids?
Maybe. Remind me.
So Newtonian fluids, like water, have a constant viscosity. No matter how much force you apply, they flow the same way. But non-Newtonian fluids, like ketchup or that oobleck stuff kids play with.
Ooh, oobleck. That stuff's weird.
Yeah. They don't follow the rules. Their viscosity changes depending on the force you apply.
That's why it's so hard to get ketchup out of the bottle sometimes.
Exactly. It's thick when it's sitting there, but becomes more liquidy when you give it a good shake. It's called the Three Stooges effect, I think.
Uh-huh. Love it. Okay, so where do MR fluids fit into all of this?
Well, MR fluids are a special type of non-Newtonian fluid, but instead of responding to force, they respond to magnetic fields.
So they're like magnetic oobleck.
You could say that. They're made up of tiny iron particles suspended in a carrier fluid like oil. When there's no magnetic field around, the particles move around freely and the fluid flows normally.
Okay, that makes sense.
But introduce a magnet and things get interesting.
What happens?
The iron particles align themselves along the magnetic field lines, forming chains. These chains act like a barrier, restricting the movement of the fluid and making it much thicker, almost solid.
Wow, so the magnet instantly changes the fluid's viscosity.
Precisely. And it's reversible too. Remove the magnetic field and the particles go back to their random motion and the fluid becomes liquid again.
That's incredible. And how quickly does this change happen?
In milliseconds. It's incredibly fast.
So we have this fluid that can transform from liquid to near solid in a blink of an eye just by using magnets. What kind of applications are we talking about here? I mean, where can we actually use this stuff?
Well, one of the most well-known applications is in shock absorbers, especially in vehicles that experience a lot of rough terrain, like military Humvees.
Humvees, huh? That makes sense. So how do MR fluids improve traditional shock absorbers?
So traditional shock absorbers work by compressing fluid through valves, which can be a bit slow and limited in how they adapt to different bumps.
Gotcha. They can't always adjust fast enough for different terrains.
Right. But MR fluid shock absorbers are different. They use an electromagnet controlled by a computer to change the viscosity of the MR fluid inside.
Okay, I'm following. So when the Humvee hits a bump,
the computer instantly adjusts the magnetic field strength in the shock absorber, causing the MR fluid to thicken. This increased viscosity absorbs more energy from the bump, making for a much smoother ride.
So it's like having a shock absorber that can think for itself. It adapts to the terrain in real time.
Exactly. That's the magic of MR fluids.
Wow. It's incredible how something so small can make such a big difference.
And it's not just about comfort either. It protects the vehicle and reduces wear and tear. It also reduces driver fatigue, which is really important, especially in high-stress situations.
So from military vehicles to, well, where else?
You'd be surprised at the range of applications for MR fluids. Think bigger. Much bigger.
Bigger, like what?
How about bridges or buildings?
Wait, bridges and buildings. Are you serious?
Absolutely. MR fluids are being used to stabilize bridges and protect buildings from earthquakes. So we were talking about bridges and buildings. How can these tiny particles in MR fluids protect massive structures?
That's what I'm wondering. I can't quite wrap my head around it.
It's all about damping, controlling the vibrations. You see, bridges and buildings, they're constantly subjected to forces that make them sway or vibrate, things like wind, traffic, even seismic activity.
Right. I know skyscrapers can sway a bit in strong winds.
Exactly. And that's where MR fluids come in. They act as dampers, absorbing that energy and reducing the amplitude of those vibrations.
Okay, I'm starting to see the connection. But how exactly do they do that?
Imagine strategically placed MR fluid dampers within a building structure.
Okay, I'm picturing it. Then what?
When those vibrations start, sensors detect the movement and activate the dampers.
So these dampers can react in real time.
Precisely. They adjust the magnetic field strength applied to the MR fluid, which changes its viscosity. And by controlling the viscosity, you control the amount of damping force.
So it's like having a super smart shock absorber for the entire building.
You got it.
Yeah.
And it's not just limited to earthquakes. These MR fluid dampers can also counteract vibrations from strong winds, heavy traffic, or even machinery inside the building.
Wow. That's amazing. So we've gone from tiny particles to Humvees to protecting entire buildings from earthquakes. What other incredible applications are there for MR fluids?
Well, let's talk about something a bit closer to home. Have you ever heard of haptic technology?
Haptic technology? Not really.
Think about it as the science of touch. It's about creating systems that allow you to feel and interact with digital environments, like in virtual reality.
Oh, like those video game controllers that vibrate when you're playing.
That's a very basic example, but yes, it's about simulating touch sensations. Now, imagine a virtual reality experience where you could actually feel the texture of objects or the resistance of surfaces.
That would be incredible. You could really feel like you're in another world.
Exactly. And MR fluids are key to making this happen.
Really? I don't see the connection.
Think about it. We need something that can change its physical properties instantly to create those touch sensations, right?
Right.
And MR fluids, with their ability to go from liquid to solid in milliseconds, they're perfect for the job.
Okay, now I see it. But how would that actually work?
Well, picture a glove, for example, with small MR fluid-filled actuators embedded in it. As you move your hand in the virtual environment, the system controls the magnetic field in those actuators.
And that changes the viscosity of the MR fluid, creating different feelings.
Precisely. So you could actually feel the weight and texture of a virtual object or the resistance of pushing against a virtual wall.
That's mind-blowing. And this could have applications beyond just gaming, right?
Oh, absolutely. Think about surgical training simulations where doctors can practice procedures and feel realistic feedback. Or physical therapy, where patients can use virtual environments to regain strength and coordination. The possibilities are endless.
This is incredible. It seems like MR fluids have almost limitless potential.
For sure.
But I'm sure there are challenges too, right? Like, are there any limitations to what we can do with them?
Of course, there are always challenges with any emerging technology. One of the key challenges with MR fluids is sedimentation. You see, over time, those iron particles tend to settle at the bottom of the fluid.
Oh, I see. So it's like the fluid separates, which would affect how it performs.
Right. Researchers are exploring different ways to overcome this, like using additives that prevent settling or developing new types of carrier fluids that hold the particles better.
That makes sense. So sedimentation is one challenge. What are some others?
Cost is another hurdle. Manufacturing MR fluids can be expensive, which can limit their widespread use.
Yeah, especially for things like large-scale infrastructure projects.
Exactly. Researchers are working on more cost-effective production methods, and hopefully, as technology advances, we'll see the price come down.
That'd be great. What about the control systems? I mean, to harness the power of MR fluids, you need to be able to precisely control the magnetic fields, right?
Absolutely. And as applications become more complex, the control systems need to be more sophisticated. We need advanced sensors, algorithms, and software to manage the behavior of the MR fluids effectively.
That sounds like a big challenge.
It is, but it's also an exciting area of research with lots of potential for breakthroughs.
All this talk about innovation is fantastic, but we also need to be mindful of the bigger picture. What about the environmental impact of MR fluids?
That's a crucial point. We need to ensure that these materials are produced and disposed of responsibly.
So are there any efforts to make them more sustainable?
Absolutely. Researchers are looking into things like biodegradable carrier fluids and developing recycling methods for end-of-life products.
That's great to hear. Sustainability should always be a priority. So with all these challenges and opportunities, where do you see the research going next? What are you most excited about in the future of MR fluids?
Well, there are so many exciting avenues to explore, but one area I'm particularly intrigued by is the potential of MR fluids for energy harvesting.
Energy harvesting. Now that's something I'm really interested in.
Imagine harnessing the energy that's all around us from vibrations and movement and converting it into usable electricity.
That'd be incredible. What role would MR fluids play in that?
Well, their ability to respond to motion and generate force makes them ideal for this. Imagine a device that can capture the vibrations from traffic, machinery, or even our own footsteps.
So we could essentially turn wasted energy into a power source.
Exactly. It's a concept with enormous potential, and MR fluids could be a key part of making it a reality.
I can't wait to see what the future holds for this technology.
It's going to be an exciting journey.
You know, it's amazing to think we started by talking about a shape-shifting robot from Terminator 2.
And now we're discussing harnessing energy from our footsteps.
It's wild how these MR fluids have so many potential applications.
It really highlights how materials science is pushing the boundaries of what's possible.
So let's dive back into that energy harvesting idea.
Sure, it's a fascinating concept, right? Using MR fluids to capture those often wasted vibrations and turn them into useful energy.
Exactly. But, you know, I still have trouble picturing how it would actually work.
Okay, so imagine a small device,
Okay,
maybe embedded in a road or attached to a machine, something that vibrates a lot.
got it.
Inside this device, you have a chamber filled with MR fluid, along with some magnets and electrical coils.
Okay, I'm visualizing it.
Now, when vibrations pass through the device, they cause the MR fluid to move around.
Right.
That movement interacts with the magnetic field, which then induces an electrical current in those coils.
Ah, I see. So the vibrations essentially get converted into electricity.
Precisely. And that electricity can then be captured, stored, and used to power things.
Wow. It's like magic, but it's real science.
And the beauty is it's tapping into a source of energy that's often just wasted.
You mentioned this technology is still in its early stages.
Yes, but there's a lot of promising research going on.
Anything you're particularly excited about?
There are some researchers combining MR fluids with piezoelectric materials.
Piezoelectric material.
Yeah, there are materials that generate electricity when you squeeze or press them.
Oh, interesting. So it's like combining two different ways of harvesting energy.
Exactly. By combining them, you can create devices that capture energy from a broader range of movements and vibrations.
That's a clever approach.
I think so too. It's a great example of how material science can lead to some truly innovative solutions.
It's incredible to think that MR fluids could play such a crucial role in a more sustainable future.
It's definitely a possibility worth exploring further. And, it speaks to the larger theme of this deep dive, the power of scientific curiosity and innovation.
Absolutely. We started with a sci-fi movie reference, delved into the intricate science of MR fluids, and now we're talking about a future powered by vibrations.
It's been quite the journey, and it just shows that science fiction can sometimes inspire real-world advancements.
And for our listeners, it's a reminder that the future is full of possibilities.
Possibilities that are often driven by the curiosity and ingenuity of people like the researchers we've talked about today.
So to our audience, if you're fascinated by this technology, I encourage you to keep learning and exploring.
You never know, maybe one day you'll be the one making groundbreaking discoveries in the world of smart materials.
This has been a truly eye-opening deep dive, and we're excited to see what the future holds for MR fluids and the countless other innovations on the horizon.
Thanks for joining us on this exploration.
Until next time, keep those minds curious and those imaginations running wild.